the atoms in the universe heavier than hydrogen and helium are forged by stars.
Stars are really interesting. They don't just sit there. They know because they last so much longer than we do. We think they're permanent.
Stars are the ultimate alchemists. They turn light elements into heavier ones. They get the energy that they need to glow that way. The star begins its life made out of hydrogen and helium mostly, about 70% hydrogen, 28% helium in the case of the sun.
In a star's core, the temperature and pressure are so high that hydrogen atoms fuse together to make helium. Hydrogen fusion releases prodigious amounts of energy, the heat and light of a star.
That's the story for 90% of the life of a star, fusing hydrogen to make helium.
Eventually, though, the star runs out of hydrogen and begins to fuse its stocks of helium, making yet heavier elements.
And so the way it works, and it always works this way, is that it contracts and it gets hotter. And if it can find something new to burn, whether it's the kitchen sink or coal or whatever, it'll burn it.
Helium is taken 3 at a time to make carbon.
You can add one more helium to that carbon and make element number 8, oxygen.
That's a tremendous step forward. You get carbon and nitrogen and oxygen made in stars.
Now this is great because on the board we already have the principal elements of life.
Organic chemistry is the chemistry of carbon.
Carbon fuses next, and still heavier elements begin to form.
Sulfur, argon, chlorine,
potassium, calcium, scandium. The pace of this gets faster and faster.
Back in the middle, silicon is starting to burn at 3.5 billion degrees, stupendous temperature.
It makes titanium, vanadium, chromium,
manganese, cobalt, nickel, and iron.
Iron is really the end of the road. It's sort of the nuclear turnip out of which you just cannot squeeze anymore.
It's the end of the game. A star that has relied on fusion has come to the point where it has nothing more to spend.
The star is suddenly caught in a disaster. There's radiation going out from the outside, but deep in the inside, there's no more fuel.
Iron can't fuel the stellar furnace. And so, when a star builds up too much iron, it dies.
The core collapses, it bounces,
and it begins to move out, first slowly and then faster and faster.
And that sends a very sharp wave back out through the star.
And now what was falling down is going out, the whole thing's blowing up. And you've made a supernova.
The supernova explosion can be as bright as 4 billion stars like the sun.
A stupendous explosion.
Such outrageous energies overcome the iron barrier, cooking atoms into all the rest of the elements on the periodic table.
So starting down here, you can go copper,
zinc,
gallium,
germanium,
arsenic,
zirconium, niobium, molybdenum, technetium, rhodium,
ytterbium,
tellurium, iodine, xenon, cesium, barium, lanthanum, cerium,
actinium, xenon,
thorium, protactinium, uranium. Done. That's enough elements.